Hello friends, I welcome you to my YouTube channel MacPM. So in today's video we will solve a simple problem which is based on stress and strain. So let's read the problem. A beam weighing 450 Newton is held on horizontal position by three vertical wires. So this is a beam, this, and it is held in horizontal position by wires. It means even after weight is applied on three wires, these wires are of same length, because if one wire is longer and if one wire is, suppose this wire was longer, this was like this, then beam will tilt like this. But beam is not tilting, it is in horizontal position. It means that even after hanging the load, the length of the three wires is same. This is the meaning of horizontal position. Then one attached to each end of the beam, okay, and one in the middle. The outer wires are made of the brass, so this is brass, this is also brass, and diameter of 1.25. So diameter of brass is 1.25 mm, and central wire is steel, so diameter of steel is 0.625 mm. Okay, if the beam is rigid, means, what is the meaning of the beam is rigid? Is that the beam is not buckling or tilting, it is just straight and in rigid position, and wires are of the same length. And before hanging the beam, also wire were of same length L, and on stress, and there was no stress on the wires, it were their natural lengths. So before the beam is estimate the stress induced in the wires, we have to find the stress sigma b and sigma steel, brass and steel. The E is given, Young modulus of brass is 86 giganewton per meter square, and E, let's move this to the side so that we can have some space. Young's modulus of steel is equal to 210 giganewton per meter square. Okay, now we have load 450 Newton. So total load P is equal to 450, which will be distributed equally on these three, which is equal to, this load will be distributed on these three wires, not equally, but it will be distributed on three wires, which is equal to PB plus P steel plus P brass, because there is 2 times brass and it is identical, so PB will be same in these two cases, which will be equal to 2 PB plus PS. This is equal to P is equal to 450. So this is equation number 1. Now even after hanging the beam, this wire are having same length, means deformation in this wire will be same. It means the strain in the brass wire is equal to strain in the steel wire. Okay, now strain can be written as stress divided by Young's modulus of elasticity. So we can write it in this form. Okay, now stress is equal to load P upon A So we have written the stress in form of P upon A is equal to PS upon AS ES. Okay, so from here we can find PS is equal to, we will move AS and ES this side, PB into AS into ES divided by AB into EB. We can put the values here. PB is we don't know. PB we have to calculate into area of steel. We know pi by 4 into d of steel, diameter of steel is 0.625 into 10 to the power minus 3 meter is square into elasticity of steel is 210 into 10 to the power 9 because it is in giganewton, that's why. Now area of brass is pi by 4 1.25 into 10 to the power minus 3 3 square into 86 into 10 to the power 9. So 10 to the power 9 will be cancelled, pi by 4 will be cancelled, this 10 to the power minus 3 is also it will be cancelled. So if we divide this, then we will get PS is equal to 0.61 PB. So this is our equation number 2. Now if we put the value of this PS in equation number 1, then we will get 2 PB plus 0.61 PB is equal to 450. So 2.61 PB is equal to 450. From here we will get PB is equal to 172.4 Newton. This is value of load carried by brass wire, and PS is 0.61 PB, which will be equal to 0.61 into 172.4. It will be equal to 105.2 Newton. So now we have calculated the load carried by these two. Now what will be the stress? Stress will be equal to load upon area. Okay, for brass load is 172.4 divided by area is pi by 4, diameter is 1.25 into 10 to the power minus 3 meter square. So it will be equal to 1.40 into 10 to the power 8 Newton per meter square, or 140 mega Newton per meter square. Now stress in steel will be equal to load in steel divided by area of steel. It will be equal to 105.2. This is load on steel wire, and area of steel wire is diameter is given as 0.625 mm. So if you convert into meter, then it will be 10 to the power minus 3 square. So it will be 3.429 into 10 to the power 8 Newton per meter square, or 342.9 mega Newton per meter square. So this is the value of stress on the steel wire. So I hope you understood this problem. If you have any doubt, then please ask in the comment section, and if you like this video, then please share and subscribe to our channel. Thanks for watching.